Hello, welcome again. We are solving Indian Forest Services Mechanical Engineering Paper 2 of year 2024. Question number 5 is explain the principle of regeneration in a steam in a simple steam power plant cycle using a schematic and TS diagram. How does it improve the cycle efficiency? What are the limitations observed? The principle of regeneration in simple steam power plant is regenerative Stirling cycle with reversible heat transfer. So this is the regenerative schematic diagram. So here starting from 1 there is expansion of steam to 2 and then it is fed to condenser and then 3 to 4 is pump, water is pumped and this water or condensate is now fed to fed around the turbine so that it gets heated, okay, and reaches to 5 and then after that it is fed to boiler, not directly go to this boiler. That is now it is fed to boiler. So that means some water gets heated when it circulates around the turbine and further heating takes place in boiler. So this is the boiler and this is your turbine. 1 to 2 is again turbine work. So in TS diagram, now if there is no regeneration, then 1 2 would be your vertical line. But now it is this inclined line. Okay, now this is inclined line. That is why the heat is transferring from this steam to this water. 1 to from 1 to 2 1 to 2 the heat is transferred from to water from 4 to 5. Okay. So now we can assume that for a small entropy change of water and for a small entropy change of steam, the temperature difference is also there. It means we can assume that at each and every point the temperature of steam and water is constant for the process to be reversible. It be a reversible process. Okay. So then this cycle reaches approaches to because there is no heat loss here. Heat that is lost here is applied to this water. So and there is no heat gain here from outside. So heat gain from outside is only during 5 months and heat loss is to the surrounding is only 2 to 3. So as there is no heat gain or loss here and no heat gain or loss here, so this process, these two processes are your constant temperature processes and these are we can say adiabatic processes because they are 1 2 is transferring heat to 5 so ultimately external heat is not there. Okay. So this cycle now approaches to Carnot cycle because no entropy change, no heat transfer, adiabatic process, and this is constant temperature. So the efficiency of Carnot cycle is maximum. So that's why if we apply this, then we can have maximum efficiency. So I am reading out for you. The principle of regeneration. The principle of regeneration in simple steam power plant is almost same as that of regenerative Stirling cycle with reversible heat transfer. In the ideal regenerative cycle, condensate after leaving pump circulates around the casing so that heat is transferred from vapor expanding in the turbine to condensate circulating around it. It is assumed that this heat transfer is reversible. At each point, the temperature of vapor is only infinitesimally higher than the temperature of liquid. The process 1 2 represents reversible expansion of steam in the turbine with reversible heat rejection to surrounding. Surrounding is this. Surrounding liquid heated reversibly in process 4 to 5. For any small steps, the slope of line 1, 2 and 5 4s are thus identical in content. 4s 5 BA 4s 4s 5 4s 5 BA 4s and 1 BC 2 are equal. So means the heat but is rejected here is observed here. So heat now heat is added from external source. The heat added from external source is Q1, that is H1 minus H5, that is T1 bracket S1 minus S2, and heat ejected at constant temperature T2 is H2 minus H2, that is T2 minus T2 H2 minus H2. Okay, so since the heat transfer is reversible process, so entropy of universe is equal to entropy of water plus entropy of steam, that is equal to 0. So entropy of water is equal to minus entropy of steam. Okay. Change in entropy of water is equal to minus of entropy of steam. So entropy change of water is S5 minus S3 or S4. It's the same entropy. Entropy change of steam is S1 minus S2. Okay. Or we can say here we have used S1 minus S2, S1 minus S5 is equal to S2 minus S3. So efficiency comes out as 1 minus Q2 by Q1, that is this is Q1, this is Q2, and this is efficiency is 1 minus T2 by T1, because these are same, so it is T2 by T1, 1 minus T2 by T1. So which is the efficiency of Carnot cycle? Okay, so ideal regenerative cycle like Stirling cycle is just equal to the Carnot cycle. Okay, so Rankine cycle approaches to Carnot cycle which has maximum efficiency. So this is your Stirling cycle. In Stirling cycle also, regenerative cycle, Stirling cycle also, the heat rejected during 1 2 is applied to 3 4, and this is your constant temperature. So these are almost same to the principle of regeneration in steam power plant is regenerative Stirling cycle. Okay, so but this cannot be approached practically because one, the reversible heat transfer cannot regions are reversible heat transfer cannot be realized in finite time. 2 or B, because we have to supply heat from steam to water, so that is reversible heat transfer, and this requires a long time, so this cannot be realized in finite time. Okay. So it is not possible. Second reason is the heat transfer in the turbine is mechanically impracticable. That is also correct, because turbine do not have any provision for heat transfer, so that is impracticable. And C, the moisture content of steam in the turbine is high, which leads to excessive corrosion of fluid. So at the exit, the moisture content is high, so it leads to corrosion of fluid. So that's why these ideal regenerative cycle is not used. A feed pump is used, but this cycle is not used. But that is the main principle.